Hello everyone, myself Dr. Praveen Kumar Balguri, working as Associate Professor in the Department of Aeronautical Engineering at Institute of Aeronautical Engineering, Hyderabad. Welcome to Aircraft Propulsion and Turbo Machinery course. In this lecture, we'll try to learn Ramjet and Scramjet engines. So far in the previous lectures, we have learned about working principles of various gas turbine engines. That is, those are turbojet and turbofan, turboprop and turboshaft engines. We have seen important components of individual jet engines, like important components in the turbojet, turbofan, and turboprop and turboshaft, and their working principles. Otherwise, their function in the jet engine, right? If you look at, we'll just recap before going to the today's topic, that is Ramjet and Scramjet. We'll just go through a few important points related to these engines. For all these four jet engines, gas turbine engines, core engine is a common one, which generates thrust or few engines shaft power, right? Like which consists of compressor. Of course, it starts with every engine starts with inlet, then compressor. Then compressed air will be sent to the combustor, where fuel will be added to the high pressure air. Then combustion takes place. Then this high temperature and high pressure exhaust will passes through or expands through the turbines, either single stage or multi-stage turbines. Then during this expansion, turbines extracts the energy from the combustion exhaust, and then exhaust passes through the exhaust section or nozzle, which converts into kinetic energy. That is what generating thrust, right? This is a common working principle of gas turbine engine or gas generator, right? And if you see, a turbojet actually, which is efficient at high speeds, that is supersonic speeds, can generate high thrust in a shorter time. So for high speed applications or military applications, jet engine is preferred, but which actually consumes more fuel and noisy as well. Whereas turbofan engine is developed to compensate the losses of limitations of this jet engine, especially for lower speeds, lower supersonic speeds or transonic speeds. Especially these turbofans are mostly used in most of the airliners. So when you're comparing with jet and turbofan engines, have advantage of fuel efficiency at low speeds, and these are noise also is being reduced with bypass air, and so that is the reason as they are economic and suitable at low speeds, and most of the airlines use this turbofan. And then next to two types of engines we have seen uses shaft power. Shaft power will be used to drive propellers. In case of turboprop, propellers generates thrust. In case of turboshaft, shaft power will be used to drive the rotor blades, right? And these two are developed for low altitude and low speed applications, and they are limited by propeller or rotor blade aerodynamics, right? These are a few important points about these four types. And we'll see, again, we'll go through the slides. In turbojet, 100% thrust is generated from the exhaust. That's one important point to remember. And components are compressor, combustor, and then turbine, and then nozzle. Then turbofan. We'll just rush through these slides before going to supersonic vehicles. turbofan engines, and this is a core engine, and additional component is turbofan, and 80% of the thrust is generated through approximately through bypass air, bypass air, bypass air, and approximately 20% of thrust is generated from the core jet engine, right? So 80% of thrust is from only bypass air, and 20% only through the core. But to generate that 80% thrust, power supplied is only from core jet engine only. So core jet engine actually in a way is functioning or running to drive this fan, which generates 80%, approximately 80% of thrust, right? So it's not like only simply independently fan can generate 80% thrust, and all this gas turbine engine is of almost no use or minor use, that is only 20%. No, entire power generated by the gas turbine engine is used to drive the fan, which generates 80%, and rest of 20% is from the core engine. I'm just revising these things as we have already discussed in detail in previous lectures. And turboprop. So this is the turboprop engine. This is a core engine, and here shaft to power generated will be supplied to the propeller through reduction gearbox. Reduction gearbox is compulsory. That is to reduce the RPM and increase the torque. And otherwise, this propeller blades can't sustain the high RPMs where at which turbines are rotating. Right? Turbines rotate at very high RPM, and those RPMs we cannot supply directly to the propellers, because propellers are not designed to sustain such high RPM. So reduction gearbox is required, and reduction, with the help of reduction gearbox, RPM is reduced to make use of propeller design very efficiently, so that it very efficiently generates thrust, right? Of course, reduction gearbox is mandatory, but it is it increases the weight and little complexity. So here almost 95, approximately 95% in a way total thrust is generated by propellers only. Few very little or minor thrust will be generated from the exhaust, or negligible. So in a way we can see propellers generates complete thrust. And turbo shaft, if you look at turbo shaft, this is a schematic of the turbo shaft, and of course components of the core engine remains the same. And here additional similar to fan or propeller, here additional component is free turbine or power turbine. It is called free turbine because it is not connected to the shaft of the high temperature or high pressure turbines. Right here, if you look at here, they are not connected. That's why they are called as free turbine. And majority of the power extracted from the turbine is used to drive the compressor, which has to make sure to continuous operation of the jet engine. And remaining power left over from the exhaust will drive the compressor, and will drive the free turbine. These turbines are connected through shaft to the rotor blades through reduction gearbox, right? So difference between turbo shaft and turboprop. Propellers rotate in vertical plane, generate horizontal thrust. Here rotor blades rotate in horizontal plane, generates vertical thrust, vertical as well as forward also. That is another complexity. This operation of these turbo shaft engines. Turbo shaft engines especially are suitable for helicopter applications, VTOL, vertical takeoff and landing vehicles, helicopter applications only. And these are the blades only have to generates lift required, that is vertical thrust as well as forward thrust also. That is aerodynamic complexity of these rotor blades. Yeah, and both engines are limited by this propeller blades or rotor blade aerodynamics. Because we have seen little terminology related to propellers also, because propellers at the tip rotates at high RPM and at the root rotates at low RPM, and when the tip reaches RPM reaches otherwise reaches sonic velocities, flow separation will take place and vortices will form, drag increases, and so on. So such complexities are there. Due to that limitations, these are only suitable for both propeller, turboprop as well as turboshaft. Both are suitable only for low altitude and low speed. When the speed and altitude increases, efficiency will decrease. And of course, both relatively consumes more fuel. Fuel consumption and little complexity are there. But when you are comparing with piston engines, this jet engine driven propeller or rotor blade engines are efficient. And today's topic are those are Ramjet and Scramjet. We'll see Ramjet engines are these are a type of jet engines, but without moving any moving components. Otherwise, without compressor and turbine, right? And these ramjet engines are generated for supersonic speeds, especially. See, if you look at components of this is a schematic of the ramjet engine. Components of this, you can see there is no compressor here, and there are no turbines here. So compressors and turbines, these are the moving components in a jet engine. So ramjet will not have or doesn't have either compressor or turbine. So ramjet engine is a jet engine without any moving components. And one important point related to ramjet engine are they cannot operate at static, that is at zero velocity. They cannot operate, right? Which means that for this ramjet engine to work, actually to start this engine to start, it requires high speed air inflow. Actually, high speed air is required. Only then it starts working. High speed air will enter through the inlet of the ramjet engine, and compression will take place at the engine due to ram effect. Ram effect means increase in pressure, rise in pressure due to high velocity inflow. So there is no compressor blade or any other work. Only pressure being increased or flowing through the inlet at high velocities. This is ram effect. So either ramjet and scramjet both compresses air due to ram effect only. There are no compressors. So for which high velocity airflow is required. So high velocity airflow, that is Mach greater than 1, that is supersonic. At supersonic or lower supersonic inflow is required, and which will be compressed and decelerates to subsonic during the flowing through the inlet only. So here inlets, function of the inlet are, it should allow high speed airflow in, right? It should handle the inlet high speed inlet air, and it will compress the air, raises the pressure, at the same time decelerates the flow to make sure that subsonic flow only enters the combustion chamber. So inlet is Mach greater than 1, that is flow velocity is greater than speed of sound or close to that. In a way, when you are comparing with jet engine, so far whatever we have discussed, that 4 types, jet engine is among 4, jet engine is suitable for high speed operation, right? This is more this engine is developed for higher speeds than jet engine, turbojet engines, right? In which supersonic speed inlet flow inflow is required, and without any moving component compressor, inlet itself compresses, raises the pressure. But another thing is it decelerates the flow. To make sure that only subsonic air flow enters the combustion chamber, and where fuel will be injected to the combustion chamber, and air fuel mixture takes place, and combustion will take place in the combustion chamber. And the exhaust, this high speed and high pressure exhaust will be allowed or passes through the exhaust section or nozzle, and it can generate high speed exhaust, and accordingly high levels of thrust. That is up to thrust generation you can expect from ramjet engine from around 20-25 kilonewton to approximately up to 400 or 450 kilonewtons of thrust we can get from these types of supersonic engines, ramjet engines. So simplicity, the good things to remember or know about ramjet engine, they are very simple in design, in the sense as there are no compressors. In earlier gas turbine engines, low pressure turbine, high pressure turbine, and then in the beginning low pressure compressor, high pressure compressor. All these things are rotor, stator blades, and their aerodynamics also. There are issues related to compressor, that is stalling and surging of compressor blades or compressors, and so on were there. So such complexity, shaft, everything, such complexity is avoided. It is very simple design, no moving parts, right? That is about simple thing, and this good things related to ramjet, and this generates very huge thrust, and these are developed for high speed applications. High speed applications in the sense like you can use them for missiles, otherwise high speed aircrafts, supersonic aircrafts, and even launch assist also. That is for launch vehicle assistance also you can use, right? I hope components and how it works, it is clear. Working principle is clear. So inlet. First point is high velocity or high speed air inlet is required, for which it requires some assistance. So usually ramjet engines are launched from some other aircraft, because only at when air in inlet air, it can get only at Mach greater than 1 supersonic speeds or close to supersonic speeds, only this engine starts working. Until then, it will be attached to the another vehicle, another craft, which takes it to such a way that inlet air is at supersonic speeds. Then only you can start. Then only this ramjet engine starts. That's how engine starts. So it requires some launching assistance. Some other craft, it should be attached to some other aircraft, right? Which helps to get Mach greater than 1 inflow, right? Then that inflow will be compressed in the inlet of the ramjet. Pressure increases, decelerates. Then that high pressure subsonic flow will be entering into combustion chamber, where fuel will be mixed, and then exhaust will passes through the exhaust section of nozzle, and then that's how it generates huge thrust which gives supersonic speeds. And this is suitable in the range of Mach 2 to 5. So ramjet engine can work efficiently within this range, okay, within these speeds, Mach 2 to 5, which means that below Mach 2, this is not efficient. If the speed increases, if it is operating such a way that it generates engine is flying at above 4.5 or 5 and crossing 5, then efficiency will decrease, right? Yeah. We'll see a few more points as well as applications or significance of these engines. So a few applications are, ramjet engines are being used for supersonic and hypersonic flight. With hypersonic means with little modification that we'll see in the next engine. Due to its high efficiency at high speeds, the point to remember is they are only high efficient at only high speeds. When it comes to high speeds, means there is a limit, that is Mach 5 here, at 4.5 to 5, especially ramjet engine, and widely used in missiles and space launch systems and experimental hypersonic vehicles. So this is the one we can see here. Boeing CIM SIM 10A bomb rack. This is a long-range surface-to-air missile, and range was around approximately 600 kilometers. Approximately around 600 kilometers was a range. This is supersonic missile, long-range surface-to-air missile, right? And this was developed during 1950s itself, 1950s and 70s. And few more examples of ramjet engine. This is one thing. 1 minute. Yeah, this is one thing developed by US. And another one is Boeing X-51A. Actually, this is hypersonic vehicle. Little modified ramjet engine, that is scramjet engine. Otherwise, Russia developed KH-31 or AS-17 missile, air-to-surface missile. Then France developed NF-MUB hypersonic missile. And then India's supersonic missile is BrahMos. This is a supersonic cruise missile. India and Russia jointly developed this. And China's is YJ-12 missile. This is long-range supersonic anti-ship missile. When these missiles operates at approximately at Mach 3 or 3.5, and range is around approximately 250 to 450 kilometer approximately. 250 to 450 kilometers. This is a range, and speeds around 2.5 to 3.5 or 4 around approximately, right? Yeah, because it varies vehicle to vehicle. And you can see here, this is BrahMos missile, and this is China's YJ-12 anti-ship missile. And next engine is scramjet engine. It is almost a modified ramjet engine. You can see here as a name, it has scramjet. So in the ramjet engine, combustion takes place at subsonic speeds. Combustion takes place only with the subsonic air inflow, because even though inlet was supersonic air, but in the inlet it was decelerated to subsonic. Now scramjet is there is no deceleration, supersonic combustion ramjet engine. Scramjet engine full name is supersonic, S for supersonic, and C for combustion. Supersonic combustion ramjet engine. If there is no SC, it is a ramjet engine. Ramjet means subsonic combustion. So next level is modified ramjet, is that is supersonic combustion is scramjet engine. Scramjet engine. These are the components of the scramjet engine. Similar to ramjet, inlet, and then combustion chamber, inlet, combustion chamber, and exhaust section. These are the three components only. Here in scramjet also, there are no moving parts, means no compressors, no turbines, no shafts. No compressor, no turbine, no shaft, no moving parts, because as this is also ramjet engine. But only difference between ramjet and scramjet are inlet. See, in both the cases, inlet design of inlet is very complex, and inlet plays major role, because dealing with supersonic speed, air in supersonic speeds, air at supersonic speed, both the cases, right? And then in a ramjet case, that particular inlet should handle that and decelerate, right? So in both the cases, with the help of oblique shock waves and normal shock wave, the deceleration will take place. Deceleration in a ramjet case also, deceleration is taking place with the help of by generating or developing of shock waves, different types of shock waves. In this also, deceleration takes place, but in the sense, deceleration in the sense, of course, we better to avoid that word deceleration here, because combustion takes place at supersonic speeds only here, right? And inlet and ramjet case, inlet decelerates. In the scramjet, there is no deceleration. Combustion takes place. The inlet makes sure that combustion takes place at supersonic speeds only. Right? Yeah, but here also in this case also, in the ramjet case, deceleration is mandatory. Here also in case oblique shock waves forms, oblique and normal shock waves forms. With the help of shock waves, some deceleration takes place, but combustion is at supersonic speeds, right? And see, in both the cases, inlet design is very crucial. Inlet design is very crucial. They should handle supersonic speeds. And in case of scramjet, it's a little more tougher or complex, because dealing with placement of shock waves is crucial in both the cases. Placement of shock waves is crucial in ramjet and scramjet, because those are the one deceleration. Those are the one decelerates the flow, right? So generation as well as placement of shock wave matters in case of inlet, and it should take. Scramjet in inlet makes sure that supersonic air only enters the combustion chamber. And see, when you are comparing with ramjet, here special or complex or advanced injectors to be developed, because air inflow here is supersonic. At supersonic, you should, whatever the injector is injecting the fuel, that should mix with air which is at supersonic. At supersonic speed only, this air fuel mixture should take place. That is a increased complexity with the scramjet engine. And another thing is, in both the cases, ramjet and scramjet, flame stability matters. Holding the continuous fire or continuous combustion, stable combustion at these high speeds, when the vehicle is moving at high speed. In both the cases, ramjet and scramjet, both are, in case of ramjet, minimum Mach 2, where in case of scramjet, minimum 5 Mach 5 to 10 or 10 plus hypersonic speeds. This speed range is called as hypersonic. Hypersonic. So minimum, both the cases, minimum supersonic speed is required. In this scramjet case, this can only this can work efficiently only at greater speeds, like more than 4.5 or above 5, right? 5 to 10 plus. Such a hypersonic speeds, only this scramjet can work effectively and efficiently. And both the cases, as air intake is supersonic, because in case of ramjet, minimum is 2. Vehicle should move at 2 or above 1, right? Here in case of scramjet, 5 to 10. So at these speeds, sustaining continuous and stable combustion is very complex, both the cases. And sustaining these speeds, both the cases, developing and having such inlets also, and controlling the placement of shock waves also complex, right? In both the cases, or especially in scramjet, fuel injection and air fuel mixture taking place of uniform air fuel mixture, and then sustaining such huge temperatures also matters in both the cases. And especially in scramjet, ramjet engine development and testing and scramjet engine development and testing, there are many failures. There are many failures due to failure of structural components. These components are unable to sustain such a huge temperatures. Both the cases, quite often the testings by different countries or organizations failed. We can see that. We can witness that, right? Because those materials could not withstand such a high temperatures. So all this matters. There are many challenges in having so far ramjet or scramjet, especially scramjet only testing took place on second scale only. Recently, very recently, in India, ISRO also developed and tested scramjet engines. But firing was few seconds. Combustion was few seconds only, right? Yeah. So if you look at ramjet, almost components are same, because there is scramjet also. There is no compressor, no turbine, only inlet, then combustion chamber, then exhaust, right? But shape of the inlet design of the inlet will vary for ramjet and scramjet, because ramjet inlet should decelerate the flow to subsonic speeds. Scramjet, there is no deceleration. It should handle and supply stable supersonic air to the combustion chamber. And combustion chamber and fuel injection and flame stability, all those things also will make sure that it sustains stable flow, stable combustion or stable flame, and then only this scramjet can be efficient. Otherwise, unstable, and at the same time, if the materials are unable to withstand such high temperatures, they fail, damage or fail. These are the few developments of a scramjet engine. So this is X-43A. This is a conceptual picture. NASA developed X-43A hypersonic experimental vehicle, also called as HyperX, right? And where engine is almost like engine is a part of airframe. Engine is a part of airframe. And another development is scramjet. And recently, ISRO tested this also. That is abbreviation is HSTDV, that is Hypersonic Technologies Demonstrator Vehicle. It was around Mach 3.5 to 4. Then another development is X-51A Wave Rider. This is also scheme or graphical picture only of scramjet engine, right? So ramjet and scramjet are supersonic vehicles. Both are developed for supersonic speeds, very high speeds. Ramjet is in the range of Mach 2 to 5, whereas scramjet is developed for hypersonic application, that is Mach 5 to 10 and above. And both the cases, both the vehicles are simple in design, in the sense there are no moving parts, simple operation also in a way, but otherwise handling such a high speed supersonic speeds, so inlet design is crucial, and placing of shockwave is crucial, because the deceleration will take place. And in scramjet, supersonic air only should be sent to the combustion chamber, and combustion takes place at supersonic. In case of ramjet, it is subsonic. And both in case of ramjet, we have seen the thrust was ramjet thrust generation. We have seen approximately 20 or 25 to 400 plus 400 or 450 kilonewton, right? In case of scramjet, starting from 45 to up to 2000 plus kilonewton thrust we can generate, right? So almost both, especially scramjet, is in experimental stage only, experimental and testing stage only. And with the help of scramjet, single stage, direct one stage launching vehicle is also that is also under experimental section. Under investigation only. They're trying to develop such a way that one engine will take the satellite to directly to the orbit, single stage to orbit, right? Yeah, these are the references I used, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.